अच्छा चलें ठीक है क्वेश्चन नंबर 14 तक पहुंचे थे वी गोइंग टू स्टार्ट फ्रॉम देयर और अच्छा नेक्स्ट वन इज कि अच्छा दिस क्वेश्चन ओवर हियर अच्छा नहीं हमने स्किप किया था अच्छा you have this question number 15 which is कि under identical conditions what's happening under identical conditions uh, even though it proceeds by the same mechanism, reaction 1 is faster than reaction 2. So there's reaction 1 and there's reaction number 2. What factor will explain this result? I said remember okay, both of them are the same type of halogen. I mean they're exactly the same type of halogenoalkane. Halogenoalkanes के जो reaction होते हैं वो substitution नहीं होते हैं कि this carbon over here ठीक है this carbon over here is going to have a positive charge जो bromine के साथ होगा ठीक है so it's going to attract किसको attract करता है I mean in both cases this carbon over here is positively charged so it's going to attract nucleophiles ठीक है for example this first one it's going to be the CN minus 1 nucleophile सारे reactions उसी तरह थे if you go back and have a look किधर है आप लोगों का this one if we इसको बाद में देखें let's अच्छा इसी पे आ जाते हैं you have CN minus 1 nucleophile and the other one has probably I minus 1 nucleophile and that would be attracted to this positive carbon atom. So both halogenoalkanes they always have nucleophilic substitution. This over here is a nucleophile. Anything that's attracted to positive charge. So what factor will explain this? So the factors that you have is okay, reaction 1 is faster. So reaction 1 is faster, which basically means that in reaction number 1, the nucleophile is probably very strongly attracted. Okay, but it's going to be very strongly attracted to the positive carbon atom. That's why the reaction number 1 would be faster, and it would be a stronger nucleophile. वो जो और ज़्यादा attract होगा. Remember all. So remember that negative charge इसके ऊपर भी है negative charge I minus 1, but all negative charges are not exactly the same. Some the negative charge density is stronger, so the attraction is much stronger. Okay, so the correct option for this would be option number C. Riba clear है बात? Binahil?
जी
ठीक है तो ये यहाँ पे एक सेकेंड अच्छा ये जिस टाइम basically all halogenoalkanes they'll undergo nucleophilic reactions. Nucleophile would come and attack the positive carbon atom. Acha khair, the next question. In the upper atmosphere, CFCs are broken down to give chlorine radicals, but not fluorine radicals. ये हमने पढ़ा भी था कल के फ्लोरीन के radicals why are they not produced क्योंकि अगर एक CFC होगा ना produce होते हैं but they are not produced in a large quantity. So if you have a CFC, so UV light के अंदर it's the Cl bond that's a lot weaker. So that generally tends to break. CF का bond because it's a smaller atoms they make stronger bonds. तो उसका जो bond होगा ना that's not going to break very easily. So C would be the correct option for this. ठीक है अरीबा clear है ये बिनाहिल
जी
अच्छा next part okay you have question 17 and amine is produced in the following reaction. What is the mechanism of this reaction? ये तो वही है halogenoalkane है तो it's going to be nucleophilic substitution. ठीक है मतलब क्या mechanism होगा कि C2H5I है so there's I and there is अच्छा H5 this carbon over here is positive this iodine over here is negative और इसके साथ वो attract होगा it's NH3 का जो न्यूक्लियोफाइल होगा ना, N उसके जो लोन पेयर्स होंगे, they're going to get attracted to this positive carbon atom, और दूसरी साइड पे ना the electrons are going to get repelled. और ये प्राइमरी है, तो प्राइमरी का SN1 मैकेनिज्म होता है. Simultaneously, hydrogens are non-existent. I mean, they're very small, so NH3 can attack the carbon directly. वो I का टूटने का वेट नहीं करेगा, और I stretch होता हुआ, it's going to break away. अच्छा, next one, we've already done that. ये वाले इस पे आ जाते हैं. The question is, deuterium is the isotope, hydrogen का isotope है, and DBr has the same chemical properties as HBr. नहीं, इसको leave this. ये भी नहीं किया. अच्छा, this one is नहीं, वो दो चीजों का mixture है. इस पे आ जाते हैं. Which he's saying that chlorine oxide free radical ClO is formed during the depletion of the ozone layer by the CFC. ये हमने reactions किए थे. ठीक है, just to revise what would happen when a CFC would react. कि ये end पे ना, what would happen is कि upper atmosphere में you'll have Cl radicals produced, जो oxygen को attack करते हैं. OCl radical produce होता है, and that OCl radical then attacks the ozone again, and वो Cl का radical दोबारा produce हो जाता है. So this process is happening. So which features are present in the chlorine oxide free radical and odd number of electrons? ये true है, क्योंकि इन दोनों के electrons अगर equal total भी करो ना, तो chlorine has 17 electrons, oxygen has a total of 8 electrons. So total electrons क्या है? It's an odd number of electrons. इसके ऊपर कोई charge भी नहीं है, so it hasn't gained or lost electrons. अच्छा, single covalent bond is true, क्योंकि chlorine forms a single bond. तो इसलिए oxygen radical बना हुआ है, because oxygen के bonds complete नहीं है. Oxygen needs one more electron, so it needs to bond one more time. Chlorine complete है, chlorine is not a radical. Dative bond नहीं, it's a normal covalent bond. Dative bond में होता है कि both electrons come from the same atom. इसके अंदर क्या है कि there's oxygen with 8 electrons, और Cl उसको एक electron अपना दे देता है, share कर लेता है. So Cl is done with, but this oxygen needs one more electron, which is why it's a free radical. What are properties of fluoroalkanes? Fluoroalkanes are CFCs. They are less reactive than corresponding chloroalkanes, which is true क्योंकि fluoroalkanes में सिर्फ फ्लोरीन होगा, और ये हमने पढ़ा है कि फ्लोरीन का जो बॉन्ड है, it's a small atom, तो it's a stronger bond. It's a much stronger bond. तो CCl chloroalkanes के comparatively it's going to be less reactive because the bond over here is going to be, this bond over here is going to be very strong. CFC सारे non-flammable होते हैं, and ये भी true है कि ये discuss किया, the CF bond is stronger than a CCl bond. Vinyl clear है? Eva clear है?
जी. Yes.
Asha, so we did this question. Then there is the compound 1,2-dichloroethane C2H2Cl2 has been used as an industrial solvent for a number of compounds, including fats, camphor, and caffeine. Which statement by the Scottish compound is incorrect? The compound can be catalytically hydrogenated. Incorrect वो कह रहा है. अच्छा, first thing, look at this molecule. उसने कहा है कि, I mean, the two carbon atoms. और ethene है. Ethene का मतलब है it's unsaturated double bond है, और एक chlorine 1 पे है और एक chlorine 2 पे है. अच्छा, so it can be hydrogenated क्योंकि remember double bonds के जो reaction alkenes के reaction होते थे. Hydrogens can get added to these two carbon atoms. Then this is also true, the compound is a planar molecule क्योंकि whenever carbon is making a double bond, just one double bond, so it's going to be fan shaped. ठीक है, तो इसकी इसकी जो geometry होगी, that would be 120-degree angle, sp2 hybridized होगा. So both carbons are identical, so they're going to be fan shaped. Cis trans isomerism show करेंगे क्योंकि there's going to be another version of the molecule which would be जिसमें bonding exactly same होगी. this carbon will have Cl and H. The other carbon would also have Cl and H, except that the Cl would be pointing downwards. Optical isomerism नहीं है. Optical isomerism होता था जब you have a carbon and it's bonded to 4 different groups. Ariba clear है? Minahil clear है?
जी.
So the next one is, which term describes the action of NaOH on bromoalkane? ये मैंने ये कर चुके हैं. Nucleophilic substitution, SN1, SN2 reactions. Then this one, X and Y are reagents required to convert 1 bromopropane to butanoic acid. Halogen की जगह CN लेके आना है. तो उसकी जो conditions थी वो क्या थी? वो ये था कि हैलोजन की जगह OH आ सकता है, हैलोजन की जगह NH3 आ सकता है, न्यूक्लियोफाइल या फिर CN आ सकता है. The conditions were कि you needed NaCN, ethanolic and reflux. That is what was needed. तो NaCN या KCN ना वो it's the same thing. अगला पार्ट अभी हमने किया ही नहीं है, कार्बोक्सिलिक एसिड्स तक हम नहीं पहुंचे. सो पहला जो पार्ट है ना, that's NaCN या फिर KCN. ठीक है, remember Na and K both are spectator ions. It doesn't matter, दोनों group 1 के होते हैं. Basically इसमें CN-1 चाहिए था. अच्छा, then you have what reactions are undergone by 2 bromopropane. So it's propane, second पे it's bromine, and you have the rest is all H. And the rest is all H. Nucleophilic substitution तो must है क्योंकि halogenoalkanes है. फ्री रेडिकल सब्स्टिट्यूशन भी हो सकती है कि इनमें से कोई भी H अगर UV लाइट होगा तो क्लोरीन, अगर लेट्स से you add chlorine and you add UV light तो रेडिकल्स प्रोड्यूस होंगे. Cl का रेडिकल आएगा वो उसके H को ना अपने साथ जोड़ लेगा. ठीक है, सो दैट इज डेफिनेटली पॉसिबल. तो ये दोनों चीजें हो सकती हैं. Then you have elimination. ये elimination हमने last reaction पढ़ा था. This was also for halogenoalkanes कि उसमें what would happen in elimination was अच्छा what would happen का elimination ये था. What would happen in elimination was that halogen would be removed अगर NaOH ethanolic यूज किया reflux. तो halogen रिमूव होगा, साथ वाले से H रिमूव होगा, alkene बन जाएगा. तो वही कुछ इसके अंदर होगा जिसका Br जाएगा और साथ वाले से H जाएगा और ये बीच में डबल बॉन्ड आ जाएगा. It would form an alkene and it's going to be called elimination reaction. ठीक है, मिनाइल अरीबा क्लियर है ये?
जी.
अच्छा, ये खैर आंखें बंद करके नहीं, सॉरी गलत. वो कह रहे स्टेज 2 किस टाइप का रिएक्शन है. तो इफ यू लुक केयरफुली एट स्टेज 2 तो उसके अंदर one of the H is getting substituted by bromine. ये वो free radical substitution है UV light वाला. उसके अंदर वो हाइड्रोजन की जगह ना you have उसकी जगह ना हाइड्रोजन की जगह ना you have these bromines getting substituted. So next is CFCs can be used as refrigerants, aerosol propellants, and fire extinguishers. What is the reason for the greater stability? के इतने stable क्यों होते हैं ये? वो कह रहे कि CFCs जैसा ये they're more stable than chloroalkanes क्योंकि उसमें फ्लोरीन आ गया. फ्लोरीन का bond is much stronger. So C is true. CF का bond टूटना मुश्किल है. इसमें CCl के bonds हैं वो थोड़े से ज़्यादा जल्दी टूट जाएंगे. खैर उसमें भी है. लेकिन वो कह रहे it's kind of more stable. फिर अगला है कि इसको skip ही कर दो. As he's saying, which of the following does trichloroethylene react to give a chiral product? तो chiral product. Chiral का मतलब है अच्छा ये काम करो सारे मुझे प्रोडक्ट्स जरा ड्रॉ करो ना कि व्हाट इज इन दो का प्रोडक्ट मुझे ड्रॉ करो मुझे बताओ इन दोनों में से कौन इसके साथ रिएक्ट करेगा इट वुड फॉर्म अ कायरल प्रोडक्ट मेरा है रीबा ये जल्दी से ड्रॉ करो एडिशन रिएक्शन होगा डबल बॉन्ड खत्म होगा बस मुझे बताना कि कायरल कौन सा होगा
सर मैं आपको पिक्चर भेज रही हूँ
ठीक है वो भेज दो ए में वो यू विल हैव सीएल नीचे भी सीएल है दिस विल बी बीआर एडेड एच है सीएल है एंड अनदर बीआर एडेड अच्छा खैर कौन सा वाला कायरल इसमें लेफ्ट वाला राइट वाला अच्छा लेफ्ट वाला कायरल मिनाइल यही था लेफ्ट वाला था
जी
अच्छा तो ठीक है तो फर्स्ट वो कायरल है 4 different groups this is different this is different this is different and this is also all 4 groups are different HCl क्यों नहीं HCl में अच्छा you have Cl and you have Cl on this and you have H and you have Cl over here अच्छा खैर the issue with this is कि पहले तो Markovnikov's rule H किसके साथ जाएगा HCl ऐड करें so H would get added to this carbon atom जो पहले से ज़्यादा H के साथ है Cl would get added to the other one अच्छा खैर the double bond would be gone from the middle now even if you check this one out it's this carbon is bonded to 2 hydrogens this carbon is bonded to 2 Cls उल्टा भी होता तब भी same होता it would not have made a difference तो ये नहीं हो सकता अच्छा खैर बाकी इन दोनों के साथ क्या इशू ये तो सब्स्टिट्यूशन रिएक्शंस थे NaOH तो I mean even if Cl gets substituted by let's say Cl or this Cl gets substituted by OH unless you don't get rid of the double bond you can't have a chiral carbon atom chiral ke liye you need 4 single bonds so substitution reactions would not lead to a chiral product Mirail Ariba ye clear hai
जी
Achha, then you have halogenoalkanes, important molecules. In particular, they undergo a range of nucleophilic substitution, which reaction only proceeds with SN1 mechanism. ये tertiary halogenoalkanes थे. ठीक है ये SN1 mechanism होता था जब किधर से ऊपर ही था. अच्छा, SN1 mechanism was a two-step reaction when the carbon was surrounded by carbon chains. So the nucleophile वो बाद में आता था पहले Cl टूटता था उसके बाद फिर जगह बनती थी तो कार्बोकैटायन के साथ OH-1 would come in would sneak in and would bond with it so it was a two-step reaction अच्छा anyways कौन बताएगा इनमें से which one is a tertiary halogenoalkane out of all these 4 अच्छा C देख लेते हैं if we draw C is 3 carbon atoms ठीक है first one is CH3 so that's that is 3 H's second C के साथ ना there's H and Br अच्छा third वाले C के साथ ना you have again CH3 अच्छा how do you know कि it's primary secondary or tertiary whatever क्या आप इस कार्बन पे देखते हो Br वाले के साथ how many carbon chains is it attached to one carbon chain on this side one carbon chain on this side and on the third side there's a hydrogen तो रीबा क्या होगा is this primary secondary or tertiary if it's attached to 2 carbon chains
secondary
ठीक है, so this one is secondary. और secondary का होता था कि mixed होता था, SN1 SN2 दोनों चलते थे. D correct option है कि D के अंदर this is tertiary, के there is C and it's bonded to 3 CH3s, CH3 on one side, C with CHs on the other side and CH3 और एक जगह पे ना I है. So that is this one over here is tertiary. और tertiary का mechanism जो है ना SN1 है. Minahil clear है? Reba, is this clear?
जी.
So next question is 4 drops of 1 chlorobutane, 1 bromobutane, 1 iodobutane were put separately into 3 test tubes of aqueous silver nitrate. A hydrolysis reaction occurred. फिर rate of formation of the cloudiness. तो वो कह रहा है कि जो speed थी ना reaction की, ये iodine वाला जो halogenoalkane है ना, उसकी speed was the fastest. तो हमने ये डिस्कस किया था कि आयोडीन का जो बॉन्ड होता है ना, that's easier to break. ठीक है, that breaks very very quickly. So it has a very weak bond. The bond energy of Rx यानी R halogen decreases from RCl to Ri. तो आयोडीन वाले जो halogenoalkanes होते हैं, they have the fastest reaction. ठीक है, reactivity जो है वो increase करती है down the group. और वो जो फ्लोरीन वाला है ना, उसका सबसे, अगर फ्लोरीन होता है ना, that would have been the least reactive, क्योंकि फ्लोरीन का बॉन्ड इतना स्ट्रॉन्ग है. So it would be very hard to break the fluorine bond. ठीक है, मेरा क्लियर है?
जी.
अच्छा, now which of the following would be suitable for use in a fire extinguisher? तो अच्छा, fire extinguishers का ये कि ये मेरे ख्याल से we should write this down कि we talked about CFCs. कुछ questions fire extinguishers के ऊपर भी है. Remember that CFCs that contain bromine also are used as fire extinguishers. They are used as fire extinguishers. So remember that CFCs are inert, but those that contain bromine, they use frequently as fire extinguishers. One to correct it definitely. Okay. Second के ऊपर I have a doubt, तो third तो definitely incorrect है. HCl is never used as a fire extinguisher. Actually, HCl could be very very dangerous. It's a very acidic gas, obviously. So उसके fumes ही बड़े toxic होंगे. So you're not going to spray HCl. इसका check कर लेते हैं quickly. It's 2008 October November 30 October November. ठीक है, so it's एक second. Give me 1 second. Second is probably not used as a fire extinguisher. Just 1 second. As the next one is, which reaction would not give propene as one of the products, adding in excess of concentrated ये वाला propene नहीं देगा. aqueous NaOH would substitute. Ethanolic NaOH होता था जिससे elimination होती थी. So that would give propene. कि अगर bromopropane होगा ना 1 bromopropane. So if you have 1 bromopropane, तो एक से Br remove होगा, साथ वाले से H remove होगा और बीच में double bond आ जाएगा. So ethanolic NaOH would produce propene. Not aqueous NaOH. Aqueous NaOH आके ना substitute कर देगा, मतलब इसकी जगह ना Br की जगह OH आ जाएगा. बाकी रिएक्शन हमने नहीं किए हुए. क्या चलेगी? तो हमने काफी रिएक्शंस कर लिए. थोड़ा सा वो अगले चैप्टर का ना बस एक ब्रीफ इंट्रोडक्शन ही हो जाए कि व्हाट आर वी गोइंग टू स्टडी इन द नेक्स्ट चैप्टर. So just 1 second, let me open the board. So next the chapter that should be alcohols. Okay, so we're just going to study the introduction of alcohols. Okay, what are alcohols? Alcohols. Alcohols have an OH group. That's the functional group. That's a functional group. They have the OH group and only the OH group. बहुत सारे groups में OH होता है, but it's remember कि carboxylic acid is not an alcohol. ठीक है. Benzene के साथ OH लगा हुआ है, that's also not an alcohol. अच्छा, most notably यही दो compounds हैं जिनके साथ OH होता है. So these two are not alcohols. It has a general formula, but most of the time complicated molecules होंगे, so this general formula would not work. But simple के लिए तो वो काम करेगा. Complicated के लिए it's not going to work because you could have multiple OH groups in a molecule. First thing is melting and boiling points are relatively higher. So they're relatively higher, melting and boiling points. Why are they higher? Because the molecule has OH in it, which indicates okay, when O and H are together, so it would be a highly polar molecule. I mean, this part would be highly polar. Not the entire molecule, only the N wala part in it, that's going to be highly polar. And it's going to form hydrogen bonds with other molecules like it, that are capable of forming hydrogen bonds. So for example, this oxygen is negative, this hydrogen is positive, and they would be attracting each other very, very strongly. So there's going to be a strong force of attraction, and this force of attraction would be hydrogen bonds. And because of this reason, the melting and boiling points are relatively higher, and also they're capable of dissolving in water. So they're very soluble in water. Why? Because because they form hydrogen bonds. ठीक है, because they form hydrogen bonds. So for example, even if there's a water molecule here, the lone pair would be attracted to the H positive. So it's going to be very soluble in water, and the solubility would decrease with size. अच्छा, why does it decrease with size? क्योंकि बड़ा molecule जो होगा उसकी मतलब carbon chain would not be forming hydrogen bonds. वो तो बस वो end में जो OH वाला part है, that's the part that is polar. अच्छा, उसके अंदर ना सिर्फ ये जो end वाला part है ना, that's the part that's polar. बाकी chain जो है वो that's non-polar. So that would not in any way that this chain over here would not, it's a non-polar chain, and it does not attract water. Biology में it's called hydrophobic. It's not going to attract water, ठीक है? तो इसलिए जितना बड़ा molecule होगा ना उतनी solubility कम होती जाएगी क्योंकि it's only this part that is water attracting. ये end वाला part. This is the only part that's hydrophilic water attracting. ठीक है, ये clear है? बिनाहिल अरीबा, is this clear?
जी.
Yeah.
तो अभी हमने बस वो physical properties पढ़ी है कि ठीक है, melting boiling point high है, क्यों? क्योंकि it's capable of forming hydrogen bonds. और हमने वो solubility का पढ़ा है क्योंकि obviously they're soluble. Why? Because they attract water molecules because they form hydrogen bonds. ये फिर हम कल कंटिन्यू करते हैं, ठीक है? चलें, ओके, अल्लाह हाफिज.